All right, we got one more problem that we'll do this morning where we have an airport and transferring from an airport to a passenger's house, and we're given a table of information. So the length compared to the price, and we're only given a few data points: 10 kilometers, 25 kilometers, 36 kilometers, costs 450, costs 810, costs 1200. First thing I always look at is just what's the change here? How much does it change by? So to go from 450 up to 810, what is that? 360? That's a plus 360. This is the plus 15. From here, 800 to 1200, I think that's plus 390. Am I doing that right? Yeah, because 400 would be then plus 11. So my first change is 360 over 15. And that comes out to be 24. I think it's too early to do mental math. Yeah, 24. My second slope, 390 over 11, is way different. Interesting. 35.45. So one option is to use your graphing calculator to get the line of regression by typing those in. A little bit more of a naive and something you can do by hand without having to have access to technology is just to average these two values right here. So if I did the average, I'd get 24 plus 35.45 over 2. And so that means that like my average cost here is 29.725. Now, I don't have a y-intercept, but I can use the middle value and write my equation in point slope form. Remember, point slope form is something I've been desperately trying to convince you is easier than finding the y-intercept. This is your point slope form. I'm just copying the x value, copying the y value, and using the average slope right there. This equation is an okay model of the data because it uses the average slope and it uses the middle point. No line is going to be perfect, so I just did the middle of the two slopes and the middle of the 2 points. Is it going to be perfect? Nope. It will be off. Now, if I wanted to use it to estimate the price for other values of distances, we can just plug those values in. So the question asks us to estimate 27 kilometers and then estimate 40 kilometers. So we'll do 27 kilometers first. I just replace the letter X with 27. And you can see really intuitively what I'm doing is I'm taking the slope and multiplying it by 2 because 27 is 2 kilometers further than the value I had before. And so if I take that and multiply it by 2, what I'm going to do is add 810 because 810 is the cost of 25 kilometers, and I'm adding 2 slopes to that. So that gives me this value here was 59-ish, so I get 869.45. The process for the other value is practically identical, where it says instead of 27, let's look at 40, like that. So now I'm moving 15 steps beyond the data that I have. And if I take my average slope times 15, I get 445. So I'm going to add 810 to 445, and I get 1255.875. Now, One of these is a better estimate than the other. This one right here on the left is a pretty decent estimate because it's, 59 bucks more than a 25-kilometer one. That seems reasonable to me. The one I wrote in blue does not seem reasonable because it's only 55 bucks more than my 36 kilometers, but I'm 4 kilometers past the data instead of 2 kilometers past the data. So if 2 kilometers past my known value right here is $55, then it wouldn't make sense that going 4 kilometers past my known value would also be $55. So that, I sorry, $59 for the first one, 55 for the second one. So the model is not perfect. And if I was to do this calculation again to get a better estimate, what I would do instead is drop 1200 right here and drop 36 right there instead of the 25, because then I'm kind of resetting my model based on the most recent piece of data. The other thing that I find unrealistic about this problem is that the beginning slope is cheaper than the later slope. That's usually not how things work. Usually, you get a discount for buying in bulk, whether that's a taxi or anything. It's like the first little bit costs more than later, usually because of like fixed costs and just how much it takes to get a job started. So anyway, thanks for watching. Let me know if anything was confusing.